Good day, distinguished committee, respected keynote speakers, fellow researchers, and all participants of the 8th International Conference on Applied Science and Technology, ICAS 2025, hosted by Politeknik Negeri Bali. It is an honor for me to present our research today. My name is Firmanilah Kamil, and together with my co-authors, Julian Purnomo, Muh Anhar, and Irianto, we conducted a study entitled Utilization of Plastic Waste as Partial Substitution of Aggregate for Eco-Friendly Concrete Innovation. Ladies and gentlemen, the background of our study is rooted in two major global challenges. First, the world is facing an environmental crisis caused by the continuously increasing amount of plastic waste, which has exceeded 500 million tons per year. Second, the construction industry remains highly dependent on non-renewable resources and contributes to approximately 80% of global carbon emission. One of the potential solutions to address both problems in the utilization of plastic waste as a partial substitution for concrete aggregate. This approach offers a dual benefit, reducing environmental pollution while also limiting the excessive exploitation of natural materials. The urgency of this study lies in the global need to address the challenges of sustainable construction materials. As the demand for concrete continues to rise, it is crucial to explore innovative alternatives that can reduce environmental impact without compromising performance. The innovation of our research is a comparative analysis of various types of plastic waste applied both in coarse and fine aggregate. By comparing different plastic in different positions within the concrete mix, the study provides new insight into their specific influence on mechanical properties. From this background, we formulate two key research questions. How does partial substitution of aggregate with various types of plastic waste affect the compressive strength of concrete? And which type of plastic waste and substitution level can produce the best mechanical performance while remaining suitable for environmentally friendly concrete? Based on the question, our research has two main objectives. First, to evaluate the effect of partial aggregate substitution with three types of plastic waste, namely PET, LDPE, and HDPE, on the compressive strength of concrete. Second, to determine the most optimal type of plastic and substitution percentage that achieve a balance between concrete strength and environmental sustainability. Allow me to explain the methodology of our research. This study was conducted through laboratory experiment using K200 grade concrete as the base material. We used several types of plastic waste as substitution materials. HDPE and PET were applied as coarse aggregate substitutes in the range of 0.27 to 1%. HDPE and PET were applied as coarse aggregate substitutes in the range of 0.27 to 1%. LDPE was applied as a fine aggregate substitute with substitution level from 10 up to 50%. The concrete mixture consists of Portland cement type 1, sand, gravel, water, and plastic waste in a specified proportion. The samples were prepared in the form of concrete cube size 15 by 15 by 15 centimeters. For each variation, we produced 3 samples to ensure reliability and accuracy in testing. Now, let me present the results of our study. Based on the compressive strength test, we found several important findings. PET at 0.7% substitution showed performance that is closest to normal concrete, with a compressive strength of 220.94 kg per square centimeter, compared to 236.8 kg per square centimeter in the control sample. LDPE at 10% substitution still produced acceptable strength values, reaching 187.29 kg per square centimeter. However, when the substitution level of HDPE and LDPE exceeded to 20%, the compressive strength experienced a drastic climb, indicating significant negative impact on mechanical performance. This result suggests that while certain levels of plastic substitution can be tolerated, excessive amounts significantly reduce the quality of concrete. Discussion. Part 1. Effect of plastic waste substitution on concrete compressive strength. First, let us discuss the effect of different plastic waste substitution on compressive strength. HDPE as coarse aggregate replacement. The use of HDPE as a substitute for coarse aggregate significantly reduced the compressive strength of concrete. A substitution of 0.27% results in a sharp decrease, and although it increases at 0.5 to 0.75%, the value remains well below that of normal concrete. This shows that HDPE has limitation in improving concrete performance, although it can be used to a limited extent for sustainability purposes. LDPE is still usable up to 10%, but at higher percentages, the compressive strength drops dramatically and is therefore not recommended. LDPE is optimal at low concentration but decreases dramatically at high concentration. Substitution of coarse aggregate using PET. PET provides the best performance among the type of plastic tested. Substitution of 0.7% resulted in a compressive strength of 220.94 kg per centimeter square, close to that of normal concrete. At 0.85%, the compressive strength remained high but decreased significantly at 1%. This shows that PET contributes positively to the strength of concrete when used in limited quantities. Part 2. Comparison of mechanical performance between substitution types. PET is mechanically superior. LDPE has a potential substitution rate of up to 10%, while HDPE provides the lowest compressive strength and is more suitable for non-structural products. Part 3. Identification of optimal substitution composition for eco-friendly concrete. PET and LDPE balance between mechanical performance and plastic waste reduction support sustainable construction. From this study, we can draw two main conclusions. 1. The effect of plastic substitution. Partial substitution of aggregate with plastic waste has been proven to significantly influence the compressive strength of concrete. The overall performance is strongly determined by the type of plastic and the substitution level applied. 2. Optimal composition. The most optimal result was obtained with 0.7% PET in coarse aggregate, achieving a compressive strength of 220.94 kg per square centimeters, which is very close to normal concrete at 236.8 kg per square centimeters. Meanwhile, 10% LDPE in fine aggregates remains suitable for light structural application. On the other hand, HDPE demonstrated the lowest performance, making it more appropriate for non-structural application. That is all from our presentation on eco-friendly concrete innovation using plastic waste. Thank you to the ICAS 2025 committee and all participants for your attention.